This course aims to provide a solid understanding of data structures and algorithms, develop skills in implementing and analyzing them, and apply these concepts to solve real-world problems. Prerequisites include a basic knowledge of programming concepts such as variables, data types, loops, and conditionals, and familiarity with at least one programming language. The course outline covers several units. Unit 1 introduces data structures, defining their types, abstract data types or ADT, and how to choose the appropriate data structure for a given problem. Unit 2 focuses on arrays, discussing array representation and operations, dynamic arrays, specifically array lists, and multidimensional arrays. Unit 3 covers linked lists, including singly and doubly linked lists, operations that can be performed on linked lists and their applications. Unit 4 explores stacks and queues, detailing these data structures, their operations, and their applications. Unit 5 delves into trees, covering binary trees and binary search trees or BST, traversal techniques such as pre-order, in-order, and post-order, and operations on BST. Unit 6 discusses hashing, including hashing functions, collision resolution techniques, hash tables, their operations, and applications of hashing. Unit 7 introduces graphs, explaining graph representation, traversal algorithms like breadth-first search or BFS and depth-first search or DFS, and shortest path algorithms such as Dijkstra's algorithm and the Floyd-Warshall algorithm. Unit 8 focuses on algorithm analysis, including asymptotic analysis using big O, theta, and omega notation, time and space complexity analysis, and common algorithm paradigms like divide and conquer and greedy algorithms. Upon successful completion of this course, students should be able to firstly explain the concept of data structures and algorithms, secondly implement and analyze different types of data structures, thirdly apply efficient algorithms to solve problems, fourthly choose the appropriate data structures and algorithms for specific applications, and fifthly, evaluate the time and space complexity of algorithms. Assessment will include quizzes and assignments which will account for 20% of the final grade, a midterm exam accounting for 30%, and a final exam accounting for 50%. The grading scale is as follows. 90 to 100% equals an A, 80 to 89% equals a B, 70 to 79% equals a C, 60 to 69% equals a D, and below 60% is an F. The primary textbook for this course is Data Structures and Algorithms in Java by Goodrich, Tamasher, and Mount. Additional resources include online resources, tutorials, and the instructor's lecture notes and materials. Classes are scheduled with lectures on Mondays and Wednesdays from 1000 am to 11:15 am, and lab sessions on Fridays from 100 pm to 300 pm.